The adaptability of these reptiles allows them to face environmental challenges and survive in diverse habitats, maximizing their resources and ensuring their continuity. Snakes, like most reptiles and amphibians, are ectotherms, a term that refers to organisms commonly known as cold-blooded. This means that your body temperature is completely dependent on the environment. Unlike endotherms, mammals and birds, which generate their own heat and maintain a stable temperature, these animals in question must absorb external heat in order to activate their metabolic functions, a key evolutionary adaptation in their survival. According to the University of Arizona, the fact that they do not generate their own heat influences various aspects of their physiology, behavior, and how they respond to changes in their environment. Thermoregulation is the process by which snakes adjust their body temperature through changes in location and exposure to heat or cold. Thus, in the cold hours of the day or in seasons of low temperatures, they look for warm and sunny places, such as stones or hot earth, which help them regulate their body and activate their metabolism. This process, called behavioral thermoregulation, is essential for their ability to move and hunt, since without the necessary heat, these functions are reduced or even impossible. In extreme cold conditions, many snakes go into brumation, a state of dormancy similar to hibernation, in which their metabolism slows down to save energy until the weather becomes favorable. Unlike warm-blooded animals, snakes, being ectotherms, do not require large amounts of energy to maintain their temperature. This implies that they can survive on a much less frequent diet than other animals. Some species can go weeks or even months without eating. The energy efficiency of these reptiles is explained by the fact that much of the energy consumed goes directly to growth and reproduction rather than heat production. According to World Atlas, this characteristic allows snakes to decrease their activity or remain dormant in times of scarcity, making the most of their resources and conserving energy without risk to their survival. Another aspect that ectothermy influences is reproduction. Snakes usually take advantage of the warm months for this activity, since the ambient heat facilitates the development of eggs in oviparous species or embryos in viviparous species. However, in the face of excessive temperatures, some snakes respond with an additional adaptation, estivation. During this period of seasonal torpor in response to extreme heat, snakes reduce their activity, protecting themselves from dehydration and exhaustion, allowing them to withstand extreme temperatures without compromising their health. A striking aspect of thermoregulation in snakes is the ability of certain species to generate heat in exceptional situations. Pythons and rattlesnakes, for example, resort to particular mechanisms to protect their young. In the case of pythons, the mother curls around the eggs and contracts her muscles to temporarily raise the temperature and promote optimal egg development. On the other hand, rattlesnakes, being viviparous, manage to increase their body temperature while pregnant, which benefits the growth of their young. Although these strategies are not frequent among reptiles, they represent a unique ability to adapt at critical moments for the survival of the species. The contrast with endotherms, warm-blooded animals, is clear. Mammals and birds, for example, maintain a constant temperature regardless of external conditions, thanks to internal metabolic processes and regulatory mechanisms such as sweating to cool down or tremors to generate heat. This ability allows them to live in a much wider range of environments. For snakes, on the other hand, dependence on the environment limits their geographical distribution, although it allows them to thrive in hostile environments or with scarce resources where other animals would have difficulty surviving.